Hi YouTube people, I'm teacher Regy Safadão, and today we are talking about the thermal surface expansion. Are you ready? So, join us! Hi YouTube friends, I'm teacher Regy Safadão, and this is our class number 3 of 6. Let's see our opening. Our channel is Mathematics with the Frontiers, and here we have classes of physics, mathematics, and English in two versions, one in English and the other one in Portuguese. Go there and visit us. Our video classes in Portuguese are really wonderful. Well, our today's class is about thermology, thermal surface expansion. Well, are you ready? So let's see our first question. See, a ceramic tile has an area of 0.198 square meters at a temperature of 15 degrees Celsius. It is known that the surface expansion coefficient of the material this piece was made is 2.14 times 10 to minus 3 over degrees Celsius. Calculate the surface expansion of this ceramic tile when the temperature reaches 45 degrees Celsius. All right, here we have an illustrative picture. And what was given? The initial surface, the initial temperature, the final temperature, and beta. All right. Well, what is required? The surface expansion. So delta S is required. Well, I used to find, first of all, I used to find the change in temperature. It is final temperature minus initial temperature. And now I'm going to show you what formula I'm going to use and find the delta S. So it is delta S is beta times SI times delta T. Okay, so as I told you, let's find delta T. So delta T is 45 minus 15. That is 30. So the change in temperature is 30 Celsius degrees. All right. Now let's plug the values into the formula. See. So delta S is beta. Beta is 2.14 times 10 to minus 3. The initial surface is 0.198 and the change in temperature is 30. Well, I'm sure you have realized it that. Just 1 second. See, let me get a laser pointer. Okay, so I'm going to multiply 2.14 by 0.198 and by 30. This is why I wrote them in gray, okay, in order to call your attention. Okay, so let's multiply. And so delta S is 12.712 times 10 to minus 3. Well, the way I used to multiply this is, I have here minus 3, all right? So I'm going to move the point 3 spaces to the left, okay? So the point is here, 1, 2, 3. You see? See how it is? So the surface expansion, delta S, is 0.013 square meters. This is the result, okay? So it was the expansion of the surface of that ceramic tile, okay? So, so far so good. Let's see question number 2. Here it is. An iron gate is 3.5 meters high by 4.5 meters long at 10 degrees Celsius. During a sunny day, it reaches the temperature of 75 degrees Celsius. Knowing that the beta of the iron is 24 times 10 to minus 6 over degrees Celsius, what will be this iron gate final area? Okay, a picture. All right. Remember, I'm going to find the area of a rectangle, okay? I have the height is 3.5 meters and the length is 4.5 meters. Okay, so I have to multiply those values like this. So the initial surface of that iron gate is 4.5 times 3.5. That is 15.75 square meters. Okay, so that is the initial surface. Well, now what was given? The initial surface is 15.75 square meters. The initial temperature is 10 degrees Celsius. And the final temperature is 75 degrees Celsius. And the beta of the iron is 24 times 10 to minus 6 over degrees Celsius. Okay. So as I always do, I do in advance, I do delta T. Okay. So it is the final temperature minus the initial temperature. I'm going to show you the formula I'm going to apply now. You see? Let me, my window. Okay. So I'm going to use this formula in order to find the final surface. All right. So let's calculate the change in temperature. So I have that delta T is 75 minus 10. So it is 65 Celsius degrees. All right. Now that we have the change in temperature, we can replace it here. Okay. And solve that formula. So the final surface is, so let's plug the values into the formula. Okay, so the final surface is 15.75 times 1 plus 24 times 10 to minus 6 times 65. Well, see the color? 24 is going to multiply 65. So this is why it is in yellow. All right, only this I'm going to do in the next line. Okay, so I have the final surface is 15.75 times 1 plus, you can see, 1,560 times 10 to minus 6. All right, so what I'm going to do, what it means that I'm going to move the point 6 spaces to the left. All right, because I have here minus 6. So the point is right here. Let's see, 6 spaces. 1, 2, 3, 4. I need to move 2 more. So I was here. 4, 5, 6. Okay, so complete the blanks with zeros. All right, and forget about this 0 in here. Okay, so I have now 0.00156, and I'm going to add up now this value. So 1 plus 0.00156. Well, this number 1 is going to be written right here, this way. Now I have that 1 plus 0.00156 is 1.00156. Now, to finish my question, I have only to do this multiplication here, okay? So 15.75 times 1.00156 is about 15.77 square meters, okay? So this is the final surface, okay? Well, let's see question number 3. Are you ready? So, come on, pay attention. Here it is. A Pyrex glass pot lid has an initial area of 50 square inches when the temperature is 30 degrees Celsius. Find the final area of this pot lid when used at 120 degrees Celsius. What it was given. Alpha of the Pyrex is 3.2 times 10 to minus 6 over degrees Celsius. Okay, here we have an illustrative picture. What was given? SI, TI, TF, and alpha, okay? What is required? Final surface is required, so SF. Oh, yes, pay attention. I have to change, okay, to turn from alpha to beta because I cannot use alpha. You see, I cannot use alpha because alpha is linear, okay? I have to use beta because I'm talking about superficial expansion. Okay, so beta is 2 times alpha. Alpha is 3.2 times 10 to minus 6. So I have to multiply by 2, like this. So beta is 6.4 times 10 to minus 6 over degrees Celsius. I'm going to use this value, forget about alpha, okay? Okay, now let's find the change in temperature. Final temperature minus initial temperature, always like this. And then I'm going to apply SF is SI times 1 plus beta times delta T. Okay, so let's find the delta T. Delta T is 120 minus 30. That is 90. So the change in temperature is 90 Celsius degrees. Okay, now let's plug the values into the formula this way. I have that the final surface is 50 times 1 plus 6.4 times 10 to minus 6 times 90. Can you realize that 6.4 and 90, I wrote them in green. Why? Because I'm going to operate only them right now. 6.4 times 90 is 576. And now 576 is going to be multiplied by 10 to minus 6. What it means? It means that I'm going to move the point 6 spaces to the left. Okay? The point is here. So let's move 6 spaces. 1, 2, 3. I need to move 3 more spaces. Let's see. 3, I was here. 4, 5, 6 spaces. So the point is going to be right here. So the result is 0.000576. And now this number 1 here is going to add up this number. So what it means? It means that this number 1 is going to be written right here. Okay, let's do it. So our final surface is 50 times 1.000576. And doing this multiplication, we have that the final surface is about 50.029 square inches. Pay attention that the final surface is a little bit more than the initial surface. Okay, why? Because there was an expansion. Okay, see, the initial surface was 50 square inches, and the final one is 50.029 or 29 square inches. This number is a bit more than the initial surface. Can you see? Very good. Let's go to question number 4. Come on. So far, so good. Okay. My window. Okay, very good. So question number 4. Sidewalk cracks occur due to constant variations in the temperature day after day. If a sidewalk is 40 square meters in area at 20 degrees Celsius, and the concrete linear expansion coefficient is 13.10 to minus 6 over degrees Celsius, find its surface expansion when the temperature reaches 40 degrees Celsius. Okay, a picture. Okay, here you can see sidewall. It's a sidewall crack. Okay, you can see what was given: SI, TI, TF, and alpha. Oh, we have to pay attention that alpha was given again. We have to change. Okay, we have to convert from alpha to beta. Okay, so what is required? The surface expansion. Delta S is required. So let's turn. Beta is 2 times alpha. So beta is, if alpha is 13 times 10 to minus 6, beta is 2 times 13. So 2 times 13 is 26. So beta is 26 times 10 to minus 6 over degrees Celsius. This value we are going to use. We are not going to use alpha. All right. Okay. So as I told you, I used to find separately. I used to find delta T, so TF minus TI. Well, let's see the formula we're going to apply. Delta S is beta times SI times delta T. Okay, so let's find the delta T. Delta T is 40 minus 20. Well, delta T is 20 Celsius degrees. Okay, now let's plug the values into the formula. So delta S is beta, 26 times 10 to minus 6. SI, 40. Delta T, 20. Realize that I wrote these 26, 40, and 20. I wrote these numbers in yellow color. Can you see? Why? Because I'm going to multiply them. I'm going to operate only them right now. So 26 times 40 times 20 is 20,800. Now, I'm going to multiply 20,800 by 10 to minus 6. What means? It means that I'm going to move the point 6 spaces to the left. Okay? So the point is right here. Let's move 6 spaces. 1. Count with me. 2, 3, 4, 5. I need to move one more space. So I was here. 5, 6. Okay, can you see? So complete the blanks with zeros, and now we have 0.021 squared meters. So this is the surface expansion, okay, or delta S if you prefer. All right. Well, this now let's see our special tanks. Just 1 second. Okay, it is now good. Well, so thank you very much for watching our videos until the end. Subscribe our channel. This is very, very important for our channel. So share this video with your friends, your classmates, your siblings, your grandparents, okay? Everybody you love, everybody you want to learn this part of the physics. And give us your like. It is really very important to us. It is important for our channel. And if you want to get in touch with us and ask what kind of subjects you need, and we are going to prepare and we're going to upload the subjects you are interested in. Thank you very much for watching. This is Teacher Regy Safadão, wishing you an excellent week. Goodbye. See you.
That's all, folks.